Okay, what does SOHCAHTOA stand for?
Sine equals opposite over hypotenuse.
Okay, sine equals opposite over hypotenuse.
Cosine equals adjacent over hypotenuse.
Okay, good.
Good job, Peyton.
Oh my gosh, guy. Wow.
Tangent equals
Forward.
opposite over adjacent.
Okay, good. Okay, what about the other three functions? What are the other three functions? Cosecant goes with sine, right? And it's the reciprocal of sine. So if sine is opposite over hypotenuse, that means cosecant is hypotenuse over opposite. Okay, what's the reciprocal of cosine? Secant, good. Secant, so that's the hypotenuse over adjacent. And what about the reciprocal function of tangent? Cotangent. And cotangent is adjacent over opposite. Okay, SOHCAHTOA only works on right triangles. That means you have to have a 90-degree triangle. Let's say this is the angle I'm using. Hypotenuse is always the one across from the right angle. The adjacent one is the one right next to the angle. And so this one would be the opposite. Okay, and then the other thing you're having to remember, if you're dealing with right triangles, the Pythagorean Theorem. Remember the Pythagorean Theorem? Okay, remember what it is? Can you tell me? Okay, which one's C?
Hypotenuse.
Okay, good. Bless you.
Oh, it's not even. Okay, when you're doing the right triangle, before you can do your SOHCAHTOA, you have to find all three sides. So what side is missing on this problem?
Hypotenuse.
Hypotenuse. Okay, so you're going to use your Pythagorean Theorem to find it. So I'd have 12 squared plus 9 squared equals c squared. So 144 plus 81. So if I add those together, I get 225. And if I'm c, I take square root. Okay, because you're doing triangles, I know when you take square root you have plus or minus, but you don't on triangles. Everything's positive. So my hypotenuse is 15. Yes.
Chloe and I have to for
Okay, so we're going to find the 6 trig functions. So sine is equal to opposite over a hypotenuse. So if this is my angle, which number is the opposite? 9. So this would be 9 over 15. And And then if you can reduce the fraction, you reduce it. So those are both divisible by 3. So this would be 3/5. Okay. Then to find cosine. Cosine adjacent over hypotenuse. So this is my angle. So the adjacent is 12. My hypotenuse is 15. So 12 over 15. And those are both divisible by 3. Which reduces to 4/5. Okay, tangent's equal to opposite over adjacent. So what's my tangent going to be? 9 over 12, good. And those are both divisible by 3, so 3/4. Okay, the other 3 are reciprocals. So we're going to take our answers and we're just going to flip them. So cosecant is the reciprocal of sine. So if sine is 3 over 5, that means cosecant would be 5/3. So what would secant be? It's reciprocal cosine. 5/4, good. And what about cotangent? 4/3, good. Now, I know the second 3 are new, but this should be like review from geometry, right? Okay, is there any questions on the first one? I like videotaping, they're very quiet. Okay, so on this one, you're gonna be given a trig function. And it's gonna say find the other 5. You do not have to draw a triangle. I draw a triangle because I think it's easiest for me to figure out what's adjacent, opposite, hypotenuse without having to think every single time that I go to find it. Okay? But you do not have to if you do not want to. Okay? So for this one I'm given sine. What goes with sine? What are they? Opposite over hypotenuse. So if I draw a right triangle, and I just pick one of the places to be my angle. So if I put my angle here, that means my opposite is 3, my hypotenuse is 4. Okay, so I need to find this third side. So I know 3 squared plus b squared equals 4 squared. So 9 plus b squared equals 16. Subtract 9, so b squared equals 7. So if I do the square root, I get square root of 7. Okay, does that break down? No. Okay, now if you got something like square root of 8, you'd want to break that down into 2 square root of 2. Okay, but square root of 7 doesn't break down. Okay, so let's find the other 5. So you already found sine. Okay, so what's your cosine going to be? It's adjacent over hypotenuse.
Square root of 7 over root of 4.
Good, square root of 7 over 4. Okay, then my tangent.
3 over the square root of 7.
Okay, so 3 over square root of 7. Now what's wrong with this, leaving this answer?
Square root in the bottom.
Okay, you can't have square root in the denominator. So what you're going to do is you're going to have to rationalize it. So you're going to multiply by the square root of 7. So I'd have 3 square root of 7 over 7. Okay, if you do your reciprocals, so cosecant, that's reciprocal of sine. So what's the reciprocal of sine?
4/3.
4/3. Secant. It's a reciprocal of cosine.
The square root of 7.
4 square root of 7. And then we have to rationalize it. So what am I going to multiply by when I rationalize?
Square root of 7.
Good. Okay, and you always do it to top and bottom. So 4 square root of 7 over 7. Okay, now cotangent, that's reciprocal of tangent. You can do reciprocal of the answer, like that you got over here, but then you still have to rationalize it. So why don't you just do the reciprocal of before you rationalize? That'll save you some time. So this would be square root of 7 over 3. Okay, now if you want to do it with this ending answer after you rationalize, then you have 7 over 3 square root of 7. Then you have to rationalize again. So then you have 7 square root of 7 over 21, which reduces the square root of 7 over 3. You're still going to end up with the same answer. So if you rationalize, when you go to flip it, look at your original before you did to flip. Okay? Save you steps. Okay, the part that I'm going to write in red, if you want to put these on the back of your paper plate, you can. You do not have to. But these are some identities that you do not have to memorize. Okay, I'm not expecting you to have those memorized, so if you want to put them on your plate, you can. Those are your cofunction identities. more example. I'll give you an answer right now. And I am going to draw a triangle. You do not have to draw a triangle. Okay, so I'm actually going to draw a triangle. You do not have to, okay? So I'm going to make this one my 60-degree angle. Okay, so what does that mean? If I make that my 60, what's my other angle going to be? 30. Okay, how do I know this?
30, 60, 90.
Okay, it is a 30, 60, 90, but how many degrees are in a triangle?
180.
180. So if you can add the other two together, this gives me 150, that means I'm going to have 30 more. Okay, I'm given that the sine of 60 is square root of 3 over 2. Sine is opposite over hypotenuse. So if this is your 60 degrees, my opposite is square root of 3. My hypotenuse is 2. Then I'm also given my cosine of 60. Cosine is adjacent over hypotenuse. So my adjacent to 60 down here is going to be 1. My hypotenuse I already knew was 2. So I don't even have to do Pythagorean Theorem on this one. Okay, so part A, you're going to find the tangent of 60. Okay, what's tangent stand for?
Opposite over hypotenuse.
Opposite over adjacent, right? Okay, and I'm looking at 60. So opposite is square root of 3. Adjacent is 1. Square root of 3 over 1 is the square root of 3. Okay, then it switches directions and I'm looking at the other angle. Looking at the 30-degree angle. So this is my 30 angle. Sine is opposite over hypotenuse. So what's my sine of 30 going to be? 1 over 2. Okay, what about my cosine for 30? Cosine's adjacent over hypotenuse. Square root of 3 over 2, because here's my adjacent, there's my hypotenuse, good, so square root of 3 over 2. Okay, then the last one, this is a cofunction identity. This is saying if I take 90 minus the angle, so tangent, we're going to find tangent of 90 minus an angle, that's the same thing as cotangent of whatever the angle is. We're actually finding the cotangent of 60 degrees. That's what the cofunction identities do. Okay, what's 90 degrees in radians? What's this in radians? Pi over 2. So you could also see pi over 2 minus theta. Okay, so cotangent of 60. Well, if I know my tangent square root of 3, my cotangent would be 1 over square root of 3. And then what do I have to do?
Rationalize.
Rationalize it. So it's really the square root of 3 over 3.